So the general course objective and contents. The main goal of this course is to give the basic knowledge of electronic devices and circuits. And of course, where we are going to use these circuits, that is the applications. Mainly, this course is going to focus on analog devices or analog electronics. You know, there is analog electronics and digital electronics. In analog, we use everything in terms of signals or AC voltage, DC voltage, and so on. But in digital electronics, everything we are going to talk in terms of bits, zeros and ones. So remember, this course electronics, it means analog electronics. So you can use any other textbooks if you want, but I prefer to use by myself this book I'm using. Oh, it's not showing in the, okay. So this is electronic devices and circuits. And also I use another book is called Linear Integrated Circuits. This is also, it's a red color book. So I had given the authors and the name and details. It's up to you. Whatever the textbook you can, you can choose. So these are the 3 books I recommend, and also some relevant references and online materials. So there are so many online references nowadays. So you can also use them. It's very useful. Maybe let us start now the introduction lecture. Okay. So nowadays we have a lot of modern systems and technologies. We are living in the modern world. We are really lucky to live in this era. So especially you have internet. That is a very powerful tool, but internet is nothing if we don't have the electronic devices. So we have mobile phones. Almost everyone have more than one mobile phones nowadays. It's called a smartphone. Smartphone was a trend few years ago, but nowadays it's very common. It's very basic in our everybody's home actually. In every single member in the family, they have the smartphone. So this is also the advancements in the technology. Because of the advancements in these technologies, there are so many modern systems nowadays. It's not a matter what kind of industry it is. We have more advancements in technologies, and we have more advanced and modern systems. So for example, in the communication industry, this is just the mobile phone is one simple and small example. And in administration, in the olden days, administration means we have to have a lot of paperwork, and we will have a big racks with a lot of papers. If we need to find some records, you need to spend a lot of time to find the paper and so on. Nowadays, we store everything digitally in the computer. If you're looking for a file, you just go to the folder. If you organize the folders properly, you just go to the folder and you can just use a keyword to search for the file name. So that is much more better and advanced. So in the administration industry, similarly in industrial systems, we have a lot of automations nowadays. Human errors are very, very common. So if you ask me to pack a chips packet, maybe I will pack 2 or 3 or maybe 5 or 10 packets as close as possible. But after that, I will be tired, and then according to my mood, then some packets may be smaller, some packets may be bigger. They won't look similar. That is just one example. So if you have the automation, then everything, just once you program in the microcontroller, everything will be controlled. Everything will look uniform and similar. So that's why when you see some chocolate packets or chocolates, just for example, it looks similar, all the chocolates. So because of automation, that is also kind of the benefit of modern technologies. So in so many industrial applications, we are nowadays using advanced systems, and also in the measurements and instrumentation. So in order to measure something, for example, in oil and gas industry, we need to measure the oil flow and the pressure and so on. Nowadays, we use the technologies, and we can easily convert the measuring parameter. Whatever we measure, these all are analog signals. You know, the world is analog. Naturally, the world is analog. So for example, if you measure the temperature of my body, that is going to be analog parameters. And if you measure the temperature or the humidity level in this room or in your room, that is analog parameter. So we have the technology to convert such analog signals into digital formation so that easily we can compute or process the data. So we can process the data, we can store the data, and we can retrieve the data anytime, whenever we want, easily. So these advancements and technologies are everywhere. And also in businesses. Nowadays, online businesses are the most common one. So if you want to buy, you just go to the browser and you just check for the product, and you just click and you pay through the online and you get the product. It will be delivered. And when we talk about a delivery, then the transportation is also very important. In the car, whatever, even if you drive in 100 kilometers per hour, you can stop the car whenever you want. So we have the technologies, we have the hydraulic brakes and advancements, we have the electronic control. And healthcare industry, in the olden days, if you get sick, what can be done? But nowadays, how many advanced instruments we have in the hospitals. So we have social media, that is one of the powerful tool we all are using now for personal use and also for businesses to earn money. So, and also entertainment industry. So everywhere in all kind of industries, we have advancements. But if you look more closer, what is the basic for all these advancements? You can develop, you can write any codings and software. Without hardware, what can you do? You cannot write any codings and you cannot compile, you cannot do the simulation. So hardware is the basic. The hardware is made by what? So we are using basically transistors. Of course, in the hardware means the backside of the hardware, we have the motherboard. In the motherboard have so many different components, different ICs and so on. So those all are electronic components. So maybe part of the motherboard will be using analog devices, partly it will be using digital, partly it will be using mixed signal ICs, and everything is mixed. Then we are just having the complete board. So all the electronics, the current modern systems and technologies are based on the basic electronic components. Of still, these are they are the same components. So you must learn the basic concept or working principle of such components and devices. Then you should also learn how can you use these components in the circuit and build the circuit for a specific application. We got so many advancements nowadays, but you should also know what stimulated this whole world to come up with a lot of innovations. Especially World War I and World War II pushed the whole world, all the countries, especially Germany and USA, and Japan, they invented quite a lot of new technologies for the war. So those technologies are introduced to the public afterwards. So so we cannot forget this World War I and II. Even though there were so many bad results, it also gave some good results. So from the technology point of view, and we started the telephone in 1815 like this, but nowadays you have the most modern smartphone in your hands. And similarly, the computers. In the olden days in 1940, the computer will be in the size of the room. But nowadays you have the small laptop. You can just carry everywhere, wherever you want. And similarly, the protocols and the internet and so on. So we are just getting more and more advanced in each decade towards advancements and technologies. So, but you should understand, whenever we have advancements, we cannot forget the basic, because we are still using the same RLC, the resistors and inductors and capacitors, and ICs means what? ICs are integrated circuits. The one everything you are doing in terms of languages, software languages. This is not a software language. This is actually for hardware design. We are using this language, special language. Software side, we use a C, C++, Java, and so on. Hardware side, mostly we use Verilog and VHDL until today. The C language we started several years ago. Until now, we are using C language in industry. Of course, we have the .NET Frame, .NET Core, but what is behind the .NET Core and .NET Frame platforms? We have the C# or C#. C# is little more advanced version of the C++. C++ is little more advanced version of the C language. But after we do the program, everything, we are programming everything in the hardware. So the hardware is made by transistors. The transistors, there are several types: bipolar transistors, field effect transistors, complementary metal oxide semiconductor transistors, so on, so on. So there are so many different types of transistors. So basically, we are using these components to build the hardware, to build the circuit, and then we can do the whatever the program into the memories, and it can perform the operations. So it's really worth to learn this subject, electronics. If you understand the working principle of these devices and how the circuit works, the same you are going to apply in even the more complex circuits. So if you just to use one resistor and one capacitor and transistor, and if you build a small circuit, if you analyze how the current is flowing, what is the voltage measurement across each device, the same principle you are going to apply even if it's going to be a very complicated circuit. So manually, we cannot really perform such calculations. That's why we have a lot of tools, simulation tools. So those tools can handle that. We program, we design, and we develop such tools by using these logics. So that is how it works. The microprocessor, how many computations is performing in the microprocessor and microcontrollers. But basically, they are using the same principle, and they made by transistors. So you should remember this electronic subject is a really interesting subject, and it's a very basic subject. Especially you are going to be an electronic or electrical engineer. It's worth to study and understand the working principle. So my goal is to give you enough theory to understand the subject. And of course, you will gain the practical knowledge in the lab. If you understand the principle, you will never forget how it works.